writing numbers in scientific notation. Here in section 1.5, the objective is to be able to learn how to use your calculator and learn what our scientific notation, what these little numbers up here mean, and how to use your calculator to manipulate those numbers. So here we go. The scientific notation is used to write very large or very small numbers. So for example, rather than have this big old long number here of 0.8 meters, the width of a human hair, we're going to write that as 8 times 10 to the negative 6 meters. So we need to understand how we get that, and hopefully what this means, and how to plug it into your calculator. Now then, if we have a very large number, like you've got 100,000 hairs, well then, how in the world did we convert that to 1 times 10 to the 5th hairs? That's what we need you to hopefully understand in this section. So numbers written in scientific notation have two parts. We have the coefficient, the 1.5, and whatever power it is written to. So you'll notice that this number right here, before the decimal, the number to the left of the decimal, it is at least 1, but it's less than 10. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. But if it's more than 9, then the number is then come here, and we're going to make the power of 10 more. So we only have one number to the left of our decimal point. So the coefficient is obtained by moving the decimal point to give a number that is at least 1, but less than 10. So for example, if we have 2,400, we need to move our decimal 1, 2, 3 places, so it's 2.4. Then we're going to say, well, how many places did we move it? Oh, we moved it 3 places. So it's to the power of 10. So 2.4 times 10 to the third. Now then, if we have this itty bitty number here, 0.00086, and we go, how do we put that in scientific notation? We still have to have one number to the left of the decimal, and then we'll figure out what the exponent, the power of 10, needs to be. So let's move our decimal 1, 2, 3, 4 places to the right, and so we're going to have a 4, and it's a negative number, negative 4. Why is it negative, whereas this one up here is positive? Well, because this is a really small number, and we have to designate that with our negative. It's less than 1 here, and so we need to designate that with a negative number. So you'll notice in table 1.2 some different powers of 10. And so 1 times 10 to the 4th is 10 times 10 times 10 times 10, and and then this one's kind of interesting. So 1 times 10 to the 0, is 1. It's not 0. We don't move the decimal any places. Whereas, anyway, so wanted to point that out. 1/10 is 1 times 10 to the minus 1. So look at that, and you can kind of understand that. So you'll notice that we do have a fair amount of measurements in scientific notation, and we use scientific notation so that we can write these big old numbers in a much more ordered way. So as we compare numbers in standard and scientific notation, you will notice we have 12,800,000 meters is the diameter of the Earth. So if we write that in scientific notation, let's move our decimal 1, 2, 3, 4, 5, 6, 7 places to get to just the number 1. So 1.28 times 10 to the 7th. Okay. Whereas diameter of a chickenpox virus is, I don't even know what power that is. I don't even want to calculate that, but let's put it in scientific notation. We got to move it over so there's the 3 before the decimal. So 0.0. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So 3 times 10 to the negative 7. And why is it a negative number there? Because this is a small number, and so writing it in scientific notation, we're going to make that designate that we had to move our decimal to the right. Okay, now then, here's the thing when you're using your calculator. Do not press your times button. Do not press multiply. Do not. There's a certain number on your calculator. It's either an EE button or an EXP button. And if your calculator does not have an EE button or an EXP button, or you can't find it, please send me a message so that I can help you walk through it on your calculator, or call the math tutor, or look up on Google and say, hey, where's my exponent key? So now then, you'll notice if you're going to press 4, if we need to show 4 times 10 to the 6th, you press 4. Do not press times. You press your EE button or your EXP button, and then put the number 6 in. And on your calculator, you're going to have some different views. It's going to look something like this. It usually doesn't look like that. Again, each calculator is different, so there's going to be a little bit of a different view. Now then, here's the other thing is if it's a negative number, a really small number, when you press in the 2.5, and then you don't press your times button, you press your EE or EXP, you must then push your plus negative button to designate the -4, and then your 4. That was the button I mentioned in the last section that was an important button to push. Do not press subtract. This is a press your plus negative button to give it a -4. And then on your calculator display, it's going to look like a variety of these. All right. So then if your calculator looks like this, so let's go backwards. If your calculator looks like this, let's see what that really means. 7.52 times 10 to the 4th. Or if it's like this, it's going to be 7.52 times 10 to the 4th. Or it might look like a 7.52 E04, which means 7.52 times 10 to the 4th. Conversely, 5.8 and a -0.2 would mean 5.8 times 10 to the -2. Or if it was 5.8 E -0.2, 5.8 times 10 to the -2. And sometimes, depending on your calculator, you can take a number and say, okay, calculator, put it in scientific notation for me. I don't want to know how to do it. And your calculator can do that. The only problem is on your first exam, that's not going to necessarily help you. I'm going to give you the number, and you're going to have to put it into the correct scientific notation. So it's just better just to learn how to do it. So a learning check. Write each of the following correct scientific notation. Okay, so let's look at this. So now then, on the 64,000, we're going to move the decimal. So 1, 2, 3, 4. We're going to need to move the decimal 4 places to get to have one number to the left of the decimal. Now then, since we moved it 4 places, that's going to be our power of 10. So 6.4 times 10 to the 4th. On the 0.021, we're going to have to move the decimal to get the coefficient that is at least 1 but less than 10. We got, in other words, one number to the left of the decimal. So let's see how far we have to move it. 1, 2. Okay. So that's a power of, we had to move it to the right. We had to move it, this is a small number, so that's 2 places. It's a -2. So 2.1 times 10 to the -2. Okay, select the correct scientific notation for each. Well, let's look and see here. Okay, so we're going to have an 8. So let's move it over. 1, 2, 3, 4, 5, 6. So it is 8 times 10 to the -6. The reason why it's -6 is because this is a small number. So we have to designate that. It's a tiny number, less than 1. So here we go on the B. 72 million. So let's see how many places over. We're going to have to move it to get to be a 7. So, and then a 0.2. 1, 2, 3, 4, 5, 6, 7. So it is 7.2 times 10 to the 7. Why is it 7 and not -7? Because this is a big number, not a tiny number. And as we see that, we can see their correct answers. And here's our concept math that hopefully you can see the chemistry in our lives.